Hi everyone. Today let us discuss about the syllabus of semester 1. This syllabus is for the students who are pursuing their physics honors. I have pursued my physics honors from the University of Calcutta. So you can say that it's a standard university. So I'm going to make the videos based on the syllabus of Calcutta University only. So you might belong to any university, so it will not affect that the syllabus is so much different. So let us discuss about the syllabus. Semester 1. First we have mathematical physics. It consists of the calculus part. You have limits, continuity, that differentiation, and so on, that graphs and all. So you have done this in your plus 2 level. It's written that it's a recapitulation. We have convergence of infinite series. We're going to deal with some series. If you people are going to take mathematics as your optional, that past subject and all, I don't know what's the term now. You people will go through these things that Cauchy's, root test, integral test, and so on. Obviously, we're going to cover it. We have first and second order differential equations. You have again gone through this. The new thing and the most important thing I'm going to introduce you is Wronskian. That's important. Of calculus of functions of more than one variable. Uh, if people are interested in qualifying IIT JAM examination, you will see that this is there in the syllabus of IIT JAM in mathematical physics. So we're going to cover it as well. And this Lagrange multipliers is also important. Hmm. So let's go to the next slide. You have vector algebra and vector calculus. This is the most important part because in future this chapter is a backbone for you. That's why when I was in my graduation and undergraduation, I used to say that mathematical physics is nothing but the backbone of physics. Please be very good in this portion. At least learn the things. That is very important because when you will go to EMT, wait, time will let you know everything. So you have recapitulation of vector algebra, the normal things you have gone, uh, linear independence, basis, representation of vectors and all, cross product. Okay, this portion you people know. People, this portion you people know. Obviously, we're going to have a recapitulation of this. The main thing is this, that vector differentiation, vector integration. This portion is not so important, but obviously we have to cover as this is in the syllabus. So we have vector differentiation. Obviously, we're going to deal with the laws and all, like Stokes law, Green's theorem, Gauss theorem, and so on. That's not EMT wala Gauss. Obviously, we're going to deal with the grad and del Laplacian operator now. We're going to see this. So let's move on the next slide. We have matrices. I know you are well acquainted with this portion. You have gone through this in your plus 2 level. Uh, you're not so acquainted with this portion, and this portion is very important, especially when you are going to deal with quantum mechanics. You are going to see these eigenvalues and eigenvector problems, Cayley-Hamilton theorem, and so on. This is only important. Uh, Actually, everything is important from your examination point of view. I'm just speaking about what is important in your future and how is the application path in physics. So diagonalization of matrix, solution of coupled linear, and so on, differential equation of a matrix are not so required, but we have to cover it as this is in your syllabus. So let's go to the next portion, like classical mechanics. No doubt the toughest part in physics. So first we have the fundamentals of dynamics, this review of Newton's law and all, and we have dynamics of systems of particles and variable mass system, rocket motion. So obviously we're going to cover each and everything. The most important things are here for that conservation of momentum and angular momentum and so on. Okay, we're going to cover everything. No doubt in that. Hmm. We have work and energy. This is a very easy chapter. We have kinetic energy theorem, that conservation of force and the relationship between force and potential. We're going to cover it. This great thing you are going to learn in mathematical physics. We have qualitative study of one-dimensional motion from potential energy graphs. Yes, the stable equilibrium, unstable equilibrium, like this, neutral equilibrium. We are going to do this. Energy of a system of particles. There is a derivation. We'll cover it. This is easy and scoring chapter. We have gravitation and central force motion. I can assure that this is the most important portion in physics. Uh, if you are not so acquainted of Lagrangian and Hamiltonian, before that, this is the most important portion of physics. Central force motion. We're going to deal with 4 points regarding central force, and there are some derivations obviously. Then we have Kepler's law, the satellite in circular orbit, and so on. There are some formulas. We're going to deal with it. This things you have gone in your plus two, but obviously we're going to deal in a advanced manner in this case. Have gravitational potential energy, that you bring a point mass here, you make a sphere, what will be the potential and all. It might be a hollow sphere or might be a full sphere like this. So we are going to deal with this as well. Have non-inertial systems. This is another important chapter that is next to important to the gravitation and central force chapter. We're going to deal with the centrifugal and core release force. This is the important one. So obviously we're going to deal with. Have rotational dynamics. Then coming to you, this is very important. These three chapters, one by one, we're going to deal. You have to remember various shapes and their moment of inertia, calculations, and so on. There are some big calculations from this chapter for this portion. They're easy, not so tough. You'll learn that in due course. We have the last chapter, the fluid motion, the fluid dynamics. Here, the Pascal's law and the Archimedes law are important. Bernoulli's theorem is always the important thing. You have gone through the Bernoulli's theorem in class 11, which is a constant. So we're going to deal the same thing. Obviously, there is a derivation. We're going to do it. Equation of continuity that renounce number, streamline, and you've gone through this. We're going to deal with in an advanced fashion the inclusion of grad and all, and so on. You can see we'll prove this. So thanks a lot for watching this video. Uh, hope we together will enjoy this learning. And I want to solve a huge number of problems, though they are not so important for your university exam. They might be useful in your competitive exams. You should prepare for competitive exams side by side. Uh, it will be helpful in your future if you are interested in pursuing higher studies. So thanks a lot for watching this video. Meeting you in the next video. Thank you.